Alright, so step one is find your critical points. That means I need to find z sub x and z sub y. So finding z sub x, the derivative of sine is cosine. And the derivative of the inside of the sine is 1/2 x squared plus y squared to the minus 1/2. And the derivative of the inside of the square root with respect to x is 2x. Okay, so this was the derivative of sine. This is what was in the sine. The derivative of the square root is this, and then the derivative of the inside of the square root is the 2x. And cleaning that up a little bit, I get cosine sub y will basically be the same, but with a y out here instead of an x.
Is there any reason why we can't divide off the top and the bottom?
Yeah, Robert, I'm gonna pretend you didn't ask that. Okay. I mean,
Oh,
cosine's a
that
function.
seems, I'm sorry,
Yeah, it's okay.
yeah, I just.
Yeah, so we'll pretend you didn't ask.
It's okay to be all that sometimes.
It would be guys and Kentucky, but then we wouldn't have anything inside of a cosine.
Everybody gets one.
I didn't see it, I didn't see it was inside of it. I'm used to parentheses everywhere, I throw them everywhere.
You know, but if it wasn't, what would be inside of it?
I just, it doesn't
Right,
stick
it didn't
out
dawn
to
on
me.
me. Okay, so we're interested in, we also should mention where it's undefined, but like where it's undefined is going to give you sharp points or asymptotes. So for this particular function, I know we don't have either of those. So we're looking for where z sub x and z sub y equal 0 at the same time. Okay, so let's think through this. This means that x times cosine of the square root of x squared plus y squared would have to equal 0, and y times cosine would also have to equal 0. So right away, the point 0, 0 comes up as a point, which is a critical value. And actually, if you look at your graph, it makes sense that that's going to be where the bottom, you know, if this were live, I could turn it upside down and we could see it. I should probably graph it. Okay, so one of my critical points is 0, 0. However, we are going to do a thorough job on this, and it's not the only place where the derivatives agree. If the square root of x squared plus y squared is any odd multiple of pi over 2, so if the square root of x squared plus y squared ends up equaling an odd multiple of pi over 2, then cosine of that would be 0, and both of these would also be 0. And we actually do see that. That's why you're getting these rings. So this, everywhere on this ring, every point is a maximum point. I've reached the top of the hill on every point on that ring, and that's where the square root of x squared plus y squared equals 1 pi over 2. So then I expanded the range of the graphing, and this is that first ring, but then there's another ring. Well, this other ring is also producing a whole bunch of maximums, it actually is where this is equal to 5 pi over 2. So what happened to 3 pi over 2? Why did I skip from 1 pi over 2 to 5 pi over 2? Right, at the bottom, there's a ring also.
Yeah.
There's a ring at the bottom, which is, every point on it is a minimum. And so that occurs where the square root of x squared plus y squared equals 3 pi over 2. And honestly, we really can't simplify this anymore. I mean, writing that down is probably the best way to write it, because it's every point on this circle. So, I mean, if you wanted to, you could actually write it more like the equation of a circle by squaring both sides, and then I would get 2n plus 1 pi squared over 4. So these are circles centered at 0, 0 with radii 2n plus 1 pi over 2. Okay, and they produce rings of maxes and minimums. So again, every point on those, you know, at the top of that hill, and then you can't really see it, but down at the bottom, there's another ring where they're all minimums. Actually, it's right here. You could actually, this is where this circle, the radius, is equal to 3 pi over 2. And here's the radius of that circle is pi. All right, so I'll get back to this, but let's go through the motions of verifying that this is a minimum. I mean, we can see from the graph it's a minimum, but let's go through the process to show that it is, okay? So that means that I need to calculate D, and in order to calculate D, I need to find my second derivatives. And they're not gonna be pretty, but once you do one, the other one will be similar to it. I guess I'll leave it as a quotient. Okay, so denominator times the derivative of the numerator, but the numerator is a product. So I have first times derivative of the second plus, but the second has all that other stuff. First derivative of the second plus the second times derivative of the first is equal to. So that's denominator times derivative of the numerator minus the numerator
Of dx.
times the derivative of the denominator.
Hey, is that test today? Is that test today? Is it? Hey, is that test today?
The denominator squared. Okay, I'm gonna step back and, just like if you are working on a big mural painting, step back and see if it looks okay from afar.
Right, but she also, no,